Good morning. Today we're going to be finishing up the unit circle. So let's review what we did last time. Last class we learned that we have degrees on the inside of our circle here. This particular degree measure is 30 degrees. We write it on the line because otherwise it gets a little complicated. The next one out, that's our 45 degrees. 60 degrees, and we're going to continue on around the circle. So there are all of our degree measures. Whenever we're working with the unit circle, we're always starting over here, going around the circle this way. So all these degree measures are of the interior angles. We also learned what radians are, and those are the arc lengths connected to those degree measures. So a 30-degree angle has an arc length out here that's a fraction of 2 pi. So the entire thing is 2 pi. Half of it is 1 pi. Half of that half is pi over 2 at 90 degrees. Half of that half of half is pi over 4. And what we discovered too was that we have different families. The 45-degree family is pretty connected to the 90-degree family. So we've got our 90-degree family here. We start over here at 0, half pi, 2 halves pi, 3 halves, or 3 pi over 2. Whoops, wrong color. And you can kind of speed through this. If you watched the last video, you already know this. Our 45-degree family encompasses that 90-degree family. So if I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. Then we have our 60-degree family. The 60-degree family also uses our 180-degree line, splitting that circle into 6 equal parts. We're splitting that pi, that top half, into 3 equal parts. So, So this is 1 pi over 3, 2 pi over 3, 3 pi over 3 at pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3 back at 2 pi. And finally, we have our 30-degree family. And the 30-degree family uses the 60 degrees, 90 degrees, and the 180 split. So all of these in blue are divisible by 30. So as we go around, this is 1/6 of that top half, so pi over 6, top half, sorry, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. All right, so those are our degree and radian measures. When you take the test for this, you'll need to know the first quadrant by heart for a proficiency level and the entire thing by heart for the highly proficient level. So we have to add something to this. Around the outside, we have a whole bunch of coordinates here. So we need to remember where our unit circle lives. So if we zoom way in just on this regular graph, we have our unit circle sitting between -1 and +1, -1 and +1. So all of these points here have an amount we go over, an amount we go up, over and up, over and up. Those are all going to be less than, or in between -1 and 1. But we're going to keep those in exact values, and I'll show you how to do that in a second. The other thing I kind of want to remind you of is anytime we're graphing a point, like, let's zoom out a little bit. If I want to graph the point 3, 4, that tells me I'm going over 3 from 0, 0, and up 4. So 3, 4. And we're going to use that same idea when we look at our unit circle in just a sec. So the first thing we're going to look at is what we know here. So we're going to start with our 30-degree angle. And we did an activity in class for this, but I'm going to redo that line. Whenever we go over and up to figure out where we're graphing something, we turn at this right angle. So what we have here is a right triangle. Now this is the unit circle, so we know that our radius is 1. And we also know that this particular triangle is a 30-degree angle right there. What you may or may not remember from geometry is that all triangles add up to 180 degrees, their angles do. So this angle is 60 degrees. What that also means is that if we were to turn this whole thing sideways, it would create an equilateral triangle. I'll just try to do it this way. That all of these would be 1. And so if we split that in half, then this is 1/2. And then we have a tool, also kind of from geometry, or you may remember from another time, to figure out what that third side length is, figure out what that x is. So Pythagorean Theorem, a squared plus b squared equals c squared. These two are the legs. That is our hypotenuse. C is our hypotenuse, and that's our longest side. Now, on this triangle, our hypotenuse is 1. So I'm going to plug that in. We know one of the legs is 1/2, and it doesn't really matter if I put that in for a squared or b squared. So 1/2 squared plus b squared, which we don't know, equals 1 squared. So 1/2 squared is 1/4. And 1 squared is 1. So I'm going to subtract 1/4. I have b squared equals 3/4. And then I'm going to square root both sides. Normally, if I square root both sides to solve, I do a plus or minus, but we're dealing with side lengths, so we're not going to do plus or minus. So b equals square root of 3 over the square root of 4. Square root of 3 I can't do anything with. That one is as simplified as it's going to get. The square root of 4 is 2. So this length right here is the square root of 3 over 2. And so, because this is 0, 0, and this is 1, 0 over here, we're living in that part of the graph. To start at 0, 0, I go over square root of 3 over 2, and I go up 1/2. So those are my coordinates at my 30-degree angle. So let's look now at, well, let's put in what we know. square root of 3 over 2, 1/2, 1, 0. We got 0, 0 over here. We're not going to deal with the rest of this right now because we're going to deal with a different triangle. So I am going to make that a little bit bigger. Now I have this point right here that I need. Again, I'm creating that right triangle. This is a 45-degree angle, which means this is also a 45-degree angle. This length is still 1. So the two lengths on the side, right here and right here, because the two angles are the same, these are the same length. So this I can call, I'm going to go ahead and call this x and x. So I'm going to use the same tool, the Pythagorean Theorem, to solve that. I've got x squared plus x squared equals 1 squared. X squared plus x squared, so that's 1x squared plus 1x squared is 2x squared. And 1 squared is just 1. To get x squared alone, I need to divide by 2. So I have x squared equals 1/2. Then I'm going to square root both sides. So I have x equals the square root of 1 over the square root of 2. And that square root of 1 is just 1 over the square root of 2. And we have that archaic rule of rationalizing. So if I have x equals 1 over the square root of 2, I'm going to multiply, and rationalizing means I can't have a square root in the denominator. I'm going to multiply that by square root of 2 over square root of 2, because that is the same as multiplying by 1. Anything divided by itself just equals 1, and I can multiply by 1. So 1 times square root of 2, just square root of 2. And square root of 2 times square root of 2 is the square root of 4, which is just 2. So my final rationalized version of this is the square root of 2 over 2. So each of these side lengths is the square root of 2 over 2. And again, since I start at 0, 0, I go over square root of 2 over 2, and I go up square root of 2 over 2. It's one of those things with the unit circle. Square root of 2 over 2 is a number. It can be approximated by a decimal, but we're keeping everything in exact terms. So you got to keep that in mind as we move forward. Okay, so finally, we're going to do the 60-degree triangle. So we have adjusting this angle right here, not there, sorry, is 60 degrees. This is 30 degrees. And that is a right angle. So we did the 30, 60, 90 triangle when we did the 30-degree angle. So now we just need to figure out what sides are what. So this is still 1. We have our equilateral triangle that we're cutting in half. That means that this side length of 1 would be split in half. So this is 1/2 right here, which means I'm going to get rid of that part, just so it's not too confusing. Which means that this tall side is the square root of 3 over 2. So we could do that math again if we wanted to. I don't really want to. So I'm going to go ahead and put in our x value, which is 1/2, and our y value, which is the square root of 3 over 2. So that is our first quadrant. So now I have all my radians and degrees filled in, and I have my first quadrant. So if I zoom on out, I know a couple things right off the bat. I have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So, pardon me. If I am looking at, say, my 30-degree triangles, I can flip that straight across. Flip it straight down. All of those triangles are going to be the same triangles. So all of these coordinates are going to be very, very similar, but with a difference in negatives. So I'm going to get rid of all my lines there. There we go. So zooming in a bit. If I have, if I've got square root of 3 over 2 here and 1/2, my x's and y's are all positive. I go right and I go up. Here when I go back, that means I have a negative square root of 3 over 2. And I still have a positive 1/2. All my y's are positive here. So all my x's, my 45 is going to be exactly the same. It's going to come over here, except it's going to be negative square root of 2 over 2. Positive square root of 2 over 2. 60-degree family is going to reflect right across to be negative 1/2 and square root of 3 over 2. So we're also going to take all of those coordinates and we're going to reflect them down. So if I have my 30-degree family here and here, I'm going to make both x and y negative here, and over here I'm going to make x positive and y negative. So I have negative square root of 3 over 2, negative 1/2. Over on the other side I have positive square root of 3 over 2 and negative 1/2. I do the same thing with my 45 family, here, here, and here. So I flip that down, they both are negative, negative square root of 2 over 2, negative square root of 2 over 2, positive square root of 2 over 2, and negative square root of 2 over 2. And the last one, 60-degree family, 1/2 and square root of 3 over 2, negative 1/2 square root of 3 over 2, negative 1/2, negative square root of 3 over 2, because in that third quadrant, those are all negative. And over in the fourth quadrant, I have 1/2 and then negative square root of 3 over 2. The last thing we need to know from this is what all of these coordinates actually are. And it has to do with those triangles again. And we're just going to do one for an example. So we'll do that 30-degree triangle. So 30 degrees here. And I'm going to remind you of some geometry stuff. Opposite side and the hypotenuse. And the adjacent side. So, when I am figuring out cosine and sine, cosine of an angle, just that baby. That was my daughter Sam, for those of you watching the video. So the cosine of theta is found by the adjacent side over the hypotenuse. So we know in this particular triangle, the adjacent side is the x value, so that's square root of 3 over 2. So the cosine of 30 is square root of 3 over 2 over the hypotenuse, which is just 1. So that just equals the square root of 3 over 2. So what we find is that all of our x values are the cosine. Sine value is found by the opposite, so the 1/2 over the hypotenuse, which is just 1/2. So the sine of 30 equals 1/2. So what we also find is that all of our y values are the sine values. So in our xy coordinates, x's are the cosine, sine y. So if I want to know, for example, the cosine of, patient Samantha, 7 pi over 4, I go to 7 pi over 4, and all I have to do is look at my x value. So that's going to give me square root of 2 over 2. If I want to know, if I want to know my sine of 120, I go to 120. There's 0, I go to 120. Sine value is my y value, square root of 3 over 2. So that is our completed unit circle. Next time we're going to be working with graphing sine and cosine graphs. So that is it for 6-2. Have a lovely day.